This video is about projectiles. This is where we've got a particle moving with a horizontal and a vertical component. So a particle P is projected from the ground with velocity of 40 meters per second at an angle of 35 degrees to the horizontal. So what we're going to do is we're going to split up the velocity into a vertical and a horizontal component. So we've got 40 meters per second at an angle of 35 degrees to the horizontal. So if we look at a vertical motion, we're going to have suvat. So S is the displacement, U is the initial velocity. So for horizontal, it's going to be 40 cos 35. For vertical, it's going to be 40 sine 35. 40 sine 35. Okay, so the first question says find the greatest height of P. So the greatest height is going to be where it reaches the top, and that's where the velocity is 0. And we know that it's going to be acting under gravity, so it's going to have an acceleration of negative g, negative 9.8. So find the greatest height, find the displacement. So we need the equation for V, U, A, and S. So the one without T in it. So that's V squared equals U squared plus 2AS. So from our suvat equations that we've done in a previous video. So we're going to substitute in the values. V is 0. So 0 squared is 0. U, so 40 sine 35 squared plus 2 times negative g times s. So we've got 40 sine 35 squared minus 2gs. We'll plus 2gs to both sides. So we'll have 2gs equals 40 sine 35 squared. Divide both sides by 2g, which is 40 sine 35 squared over 2g. Now we can grab our calculator and we can work this out as a decimal. So we've got 40 sine 35 squared over 2g, so 2 times 9.8. So that's to 3 significant figures. We've got 26.9 meters. Or to 2 significant figures, we've got 27 meters. Let's do 2 significant figures. We use G to 2 significant figures. So we'll use S to 2 significant figures, which is 27 meters to 2SF. Part B, find the horizontal distance traveled by P before it hits the ground. So what do we know about horizontal? We're going to work out the displacement. The initial velocity was 40 cos 35. The final velocity will also be 40 cos 35 because there is 0 acceleration horizontally and we don't know the time. and we're going to need to know the time to work this out. So we will work out the time from the vertical component. So we need to know the time when it hits the ground. There's two ways of doing it. We could work out the time when it's on top and then just double it, because it's going to have a symmetrical motion up to the top and then back down. Or we could work out the time for the whole motion, which will probably be a more complicated formula. So if we work the time to the top and then double it. So if we do v equals u plus at for the vertical, so for vertical motion, v equals u plus at. So this is vertical motion to the top. So at the top, v is 0. U was 40 sine 35. A was negative g. And we've got times t. So if we plus gt to both sides, we're going to get gt equals 40 sine 35. And divide both sides by g. So the time to the top is 40 sine 35 over g. I'll put to the top because we're going to have to remember to double this. So 40 sine 35 over g. Sine 35 over g, which is 9.8, gives us a time to the top of 2.34, which means total time is double our answer, which is 4.68 seconds. So 4.68 seconds. We're going to keep that in the calculator, and we're going to use s equals ut plus half at squared. So the displacement is ut plus half times at squared. Remember, a is 0 for the horizontal component, so that just leaves us with s equals ut. So displacement is 40 cos 35 times 4.68. So it's our answer times 40 cos 35. And that's 153 meters, or two significant figures again, that's 150 meters. So 153 to three significant figures, or 150 to two significant figures. Okay, another question. A particle P is projected with a velocity of 15I plus 20J meters per second. So we've got a horizontal component of 15 and a vertical component of 20. From a point 12 meters above the ground, find the speed, so not velocity, the speed of the particle after 2 seconds. So we've got, so if we look at our vertical component, so we don't know the displacement after 2 seconds. We know the initial vertical component of the velocity was 20. We need to know the v. The acceleration is negative g, and it's after 2 seconds, so that's 2. So we can work out using v equals u plus at. So it's going to be 20 plus negative g times 2. So 20, take away 2 g's. 20, take away 2 9.8s. And that gives us 0.4. So 0.4 meters per second. Now our horizontal component, there's no acceleration horizontally. So we're going to have v, it's going to be the same as u, which is 15 meters per second. We want the speed, so the speed, if it goes along 15, up 0.4, what is the speed? So it's Pythagoras. So speed equals the square root of 15 squared plus 0.4 squared. And that's, well, 15. So to two significant figures, 15 meters per second. Find the greatest height of P. So the greatest height is when it's at the top, so when V equals 0. So vertical component again. So we want to know the displacement this time. U was 20, V is 0, the acceleration is negative g, and we don't know the time. So we can do v squared equals u squared plus 2as. So 0 squared, which is 0, equals 20 squared plus 2 times negative g times s. So that's 0 equals 400 minus 2gs plus 2gs to both sides, and divide both sides by 2g. So 400 over 2g, or 200 over g, meters. We could type it into the calculator and give a decimal. We don't need to. We can leave it as 200 over g, and I think that'd be easier. So it started 12 meters above the ground. It started 12 meters above the ground. So the greatest height is 200 over g plus 12 meters. So it's gone up 200 over g meters, but it started 12 meters above the ground, so its greatest height is those two added together. Part C, find the horizontal distance traveled by P before it hits the ground. So we're going to need to work out the time it takes to hit the ground. So let's do it for the whole journey this time. So vertically, so the displacement is negative 12. To hit the ground, it's gone down 12 meters. It started out with a speed of 20. We don't know V. We know A was negative G. And we want to work out the time. So we can use S equals UT plus half AT squared. So we're going to have what looks like a quadratic here. So S is negative 12. That equals UT, so 20t plus half times negative g t squared. So negative 12 equals 20t minus And if I use g as 9.8, half of 9.8 is 4.9, so minus 4.9 t squared. I'm going to make the 4.9 t squared positive, so I'm going to plus it to both sides, which can be 4.9 t squared. I take 20t away from both sides, minus 20t. I've still got minus 12 on the left side, equals 0. So we're going to use the quadratic formula. So t equals minus b plus or minus the square root of minus b, and so b squared minus 4ac all over 2a's. And we're going to type it into the calculator. So we've got minus b, do the plus first, the square root of minus 20 squared minus 4 times a times c, which is minus 12, over 2a's, which is two 4.9's. So we get an answer of 4.61. And I expect for the negative, if we change the plus to a minus, this will give us a negative answer, which we can't use. So t can't be negative. So we've got a t of 4.61. I'll store that as a, just in case I need it. So the time is 4.61. So looking at the horizontal component now, remember s equals ut plus half at squared. There's no acceleration horizontally, so s equals u times t. U is 15 meters per second, so it's 15 times by our answer of 4.61. And that gives us, to two significant figures, 69 meters. So 69 meters to two significant figures. Okay, a particle P is projected from a point O with velocity u meters per second, an angle of theta to the horizontal. When P has moved the horizontal distance x, its height above O is y. So we're going to show that y equals x tan theta minus gx squared over 2u squared cos squared theta. So we're just going to look at our one equation for the horizontal distance x, one equation for its vertical displacement y, and we're going to combine them together and hopefully we'll get this result. So we're going to write down our horizontal information and our vertical information. So our horizontal distance is called x, u, so it's got a velocity of u, an angle of theta. So horizontally, we've got u cos theta. Then remember, acceleration is going to be 0 for the horizontal component. For the vertical component, the distance, the displacement is going to be y. U is going to be u sine theta. A is going to be negative g. and the time should be the same for both of them, so we can call both the times t. So let's use s equals ut plus half at squared. Horizontally, it's just s equals ut because a is 0. So x equals u cos theta times t. And vertically, again, s equals ut plus half at squared. So it's going to be y equals ut, so u sine theta times t, plus a half times negative g t squared. Okay, we're going to rearrange the horizontal part to make it t equals, so we divide both sides by u cos theta. So t equals x over u cos theta. So we're going to use this to substitute in to our vertical one. If we just tidy it up a little bit first, so we'll go with y equals ut. No, we'll just leave it there actually. So u sine theta times t minus, it's going to be negative, gt squared over 2. Now we're going to substitute t. We'll substitute in for t. We're going to substitute in x over u cos theta. So we've got u sine theta times x over u cos theta minus g over 2 times t squared. So it's x over u cos theta squared. So we've got on top here, we've got ux sine theta over u cos theta. And we'll leave the g over 2 for now. We're going to square top and bottom. So we've got x squared over u squared cos squared theta. So on this part we can cancel the u's. So we've got x sine theta over cos theta. And if we multiply these together, that's going to be gx squared over 2u squared cos squared theta. And we can change sine over cos into tan. So that's x tan theta minus gx squared over 2u squared cos squared theta. And hopefully that's what we wanted. So there's our answer.